Welcome to part 3. Now, it's normal for me just to save as I go along, and I don't think I called attention to how we save files in SolidWorks and when you should save. My advice would be to save as often as you choose not to lose something, or just save often. So, if you haven't saved your model yet, the first thing is be aware of where you're saving it. The second thing, give it a unique name. So here I'm going to go to File and Save As, or if you just hit the Save button for the first time, this is what you'll get. Now I have a pretty deep folder structure, but I do have a folder here called the PCC Summer Internship. That is the great class I get to share with all of you. So inside that folder, and again, I don't care where you save, but as long as you pay attention to some physical place for you to save, then that's fine with me. Just be able to get back to your file when you need it. I'm going to call this the MFI PCC Box 2024, and that will be the name of the part file, and we click Save. It says it already exists because I just did this once, but we'll click Go. Okay, so here is our block, and it is named MFI PCC Box 2024. It's also echoed right here, so this is the name of the part right here. When you work on this part, you'll see an asterisk pop up when you make changes. So anytime you make a change or you add something to this file, you'll see a little asterisk. Do not assume that autosave is set and everything will be taken care of. This is not saving to the cloud. You actually have to hit save every once in a while. So this first step is important, as are subsequent or future saves. Now that we've saved our model, let's go back to the intent. If our box is supposed to hold something, then we should probably hollow this box out. And as you learned in our first lecture, the shell command is a wonderful command that allows us to hollow something out. So in our model, we use our favorite key, the S key, that's shortcut and search, and we'll search for shell. Here's shell right here, and shell has two inputs that you're going to want to pay attention to. The first one is D1 at the top, that's the thickness, and the thickness for your box today will be 0.040 inches, 0.040, or 1 millimeter. So if you type in 1 mm, that's the same as 0.040 inches. Just make sure that your numbers match whatever unit system you're working in. And now we move to the next box. So the first box, it might be a different color depending on how your standard settings are set, but it's a green box, a blue box, or an orange box. The first box that you see is faces to remove. We're going to remove the top of the box to hollow that out. Our settings are 0.040, and first face is the top face, and we'll click Go. And what that's going to do is hollow that box out. So now our box is hollow, and that's our first step. The next thing is, we didn't really intend for the box to be this tall. This is just the primitive shape of the box. This is the easiest way to get the overall shape, was to build this taller complete box. Looking back at our picture, we see that it is foreshortened by some amount, and we don't know exactly how far that is yet. So we'll just take a guess and we'll change it later. So to do that, all I really have to do is draw a line across some section here in the middle and position that line where I think the cut should be, and then we'll do an extruded cut feature that will remove the top of the box. So the first step is on the front plane. I will sketch. I will draw a line, in this case just a horizontal line, and make sure that that line is horizontal. So once we've drawn the line, there should be a little icon in the middle saying it's horizontal. If it's not, stop and ask. And then let's add a dimension, and the dimension will go from the bottom of the box up to that line. And it really doesn't matter what that number is at this point. I may just set it to 3 inches for now, but we can always change it later depending on how we want to size or what look we want to see. We'll click OK to that, and we will Well, we actually don't need to close the sketch in this case. There's no reason to close the sketch because we can go right into the feature, and in this case, it's an extruded cut. And that extruded cut may or may not preview for you. So here's our line. It's right in the middle of our box, and it's going to cut forward and back. But if yours is not cutting, we need to change away from blind and set it to through all, because that cut really will go through all. So again, if you do not get the preview, change from blind over to through all, click the green check, and there is our completed box. And this looks a lot closer to our existing design. I'm going to save that just to get that out of the way. Next, the box is going to be sheet metal, and by that I mean we have to form it from a flat piece of metal. And as I scroll down, you'll see these different ways that we're manufacturing this part. And when I unfold it, this is the shape I'm going to see. So it unfolds into a shape like this, and we can add text to it if we want. And then we're going to refold it into a sheet metal part. So the idea here is that at this point in our model, where we are right now, we need to take the box and rip it so that the sides come apart and flatten it into this flat shape that we can cut out. The command that we're going to use to rip this box, oddly enough, is rip. So I'm going to activate the sheet metal tab or toolbar. And if you don't have that, right click on the words of the tab and you should see a selection called tabs, and near the top you'll see sheet metal. Notice that these are not in alphabetical order. They're in the order that you most often use something. So sheet metal should be somewhere in your list, but not necessarily alphabetic. You'll turn on the sheet metal tab. There'll be a dedicated class if you take a CAD class for all of these tools, but we'll look over to the right, and here is our rip command. Rip is going to do just what it says. So we're going to activate the rip command, and it's a very simple setting. There's going to be a selection of sides that go in here to literally rip them apart. And I'll set the gap to something a little bit larger so you can see it when it rips. We'll set this to 0.15. That should be a large rip and you should be able to see it. So I'm going to start selecting edges, and I think that I want to select maybe the edge to the right of the large face. So here's my large face, here's my triangular face, and I'll pick the edge to the right of the large face. And as I rotate around, I just keep picking the same edge to the right, and the same edge to the right, and the same edge to the right. So there should be 4 selections, 4 edges in this box, and we'll click the Go button. Now, I made a rather large rip, and you can see that it actually took my model and ripped this apart. And as I rotate around, here's another rip, here's another rip, and here's another rip. Now I'm going to go back in and change that rip size. And we'll change it back to something a little bit smaller. Maybe 0.03 for now. Okay, now you can still see through there. You know it's ripped, but that rip is much smaller. The next thing is, I know that there is a corner area down here that's going to cause me some problems. And this corner is not going to fold or unfold very well. So I'm going to do a little bit of manual work to take care of this area here. So I'll just click on the bottom of the part. Again, this is the bottom of my model. Click once and we'll open a new sketch. I'll draw a circle that partially intersects that corner. It doesn't, in fact, maybe to make this easier for you, let me undo that, and I'll draw a circle from the corner of the box. From the corner, and let's just go in and intersect the region that's going to get kind of chewed up. So the center of the circle is going to be on the corner of the square, and it just extends far enough to kind of encompass that gap, and that's good for one corner. Now I'll hit Control 8. Control 8 is going to get me to the bottom of the box, but you can also use the space bar, and the space bar would allow you to kind of spin this model and select maybe that bottom face as well. Here's my circle. I'd like to get 4 circles around there. One of the ways that I could get 4 circles around there is to put a center line in, and then just do a mirror. And I'm just going to quickly show you that we can do a mirror here. I could draw another center line and do a mirror. But I'm really curious if from here I can take this circle and do a circular pattern. And a lot of you might question, wait a minute, we have a square. How in the world can you do a circular pattern around a square? And let's just see if we can figure this out. So we're going to search for circular sketch pattern. Again, it's the same thing as hitting the S key, S for search, circular sketch pattern, and it asks for an X and Y coordinate. Well, that's 0, 0, so we're good there. We're going to rotate through 360 degrees, equal spacing, 4 things there, and then down here at the bottom, it wants the entities to pattern. And you should be able to just click on that circle. And if you do this correctly, then you should get this large blue circle, and you should get 3 additional circles, and that is a circular pattern around a square. We'll click the green check to accept that, and I do see that I have a circle here. I have a circle here, circle here, and a circle here. With those 4 circles, we'll go to Features, Cut, Blind, and I think I want to go just beyond the thickness, so let's set this to 0.050. That's a little beyond the thickness, and let's see what that cut is going to look like. It may not go far enough, but let's click Go and see what happens. Well, it might work. It might. That's just cleaning up that edge just a little bit. Now, we have our solid made, so if I rotate back, we have our solid, we shelled it out, we cut it down to a more reasonable size, we ripped those faces apart, and there you can see the rip and the rip, and then we did a cut to kind of clean up that corner. And the last thing we're going to do is on the sheet metal tab, we're going to insert bends. And insert bends is going to create a sheet metal part for us and unfold this thing and then refold it. So it's going to attempt 3 things. The first thing, turn everything to sheet metal. The second thing, try to flatten this and make it a flat pattern, basically. That's what we're going to cut. And then it will refold it, and we should see a completed sheet metal part folded up when we're done. The first box that it wants is the fixed face or edge. That's going to be the bottom. It could be the inside bottom or the outside bottom, doesn't matter, but it's going to be the square bottom of our box. The bend radius is going to be 0.031 or 1/32 of an inch, 0.031. And for bend allowance, we're going to click the bend allowance, and K factor of 0.5 is a good start. So if it says something else, you're going to pull down for bend allowance, set it to K factor, and a value of 0.5 is a reasonable start. And we'll click Go. Now, no bends found is an error. That's okay. SolidWorks is telling us more up here. This process bend feature failed due to the failure of flatten bends 1, which means it's not able to flatten this. Okay, that's fine. No worries, we failed, but I think it might have something to do here with this corner. This is really an ugly corner. So you can see that we have errors here. We have the sheet metal tab that comes in, and then flatten bends is a problem. It's not able to flatten these. If it can't flatten them, certainly it can't process them back into the folded state. So you can hit the undo key, or you can delete those features. I would hit the undo key, which is Control Z, or this icon right up here at the top. You want to get back to the cut extrude, and let's go and make that a little bit deeper. So edit feature. Let's see how deep we have to go to completely erase some of that garbage. How about 0.1? Let's see if 0.1 is enough. Close. And maybe let's go in and change the diameter. So if we click on Cut Extrude 2, edit sketch. Did I have a diameter? Actually, I didn't dimension this at all. So let's add a dimension. It says that it's 0.097, close to 0.1. Let's make it 0.2. And we'll close the sketch. So now I've done a better job of cleaning up this corner. So let's try this again. Insert bends. So from the sheet metal tab, insert bends. The first box wants the fixed face. That's the bottom of the box. 0.031, bend allowance, K factor, okay, and go. And it worked. That's what we needed. We needed to clean up this corner just a little bit. I know it looks bad, but if we were to weld this box, we can just weld up that corner and grind it flush as we would weld up those sides. So that's not too bad. Right now, our sheet metal tab came in. We have a flatten, so it's going to flatten everything, and you can kind of see the sketch as it's showing everything flat here, and the process bends is going to fold it up again. And on the sheet metal tab, we have this icon called flatten. If I click this button once, you'll see that it flattens everything. And when I click this button again, it will fold everything up. Okay, so you have designed your very own faceted sheet metal box in the CAD system. It hasn't been very hard to draw, and we can create different versions of this, but this is a good start. Now let's go back to our original concept. I think the box should be slightly taller. So to me, this box is a little bit too short. So in SolidWorks, if I click on any bit of this model, as I click through the different features, SolidWorks will give me access to the dimensions that build those things. So each sketch will have the dimensions and these little blue handles. And as I drag the blue handles, I can actually change the model. So a lot of people criticize SolidWorks as not being a push-pull modeler. And I'll say, of course it's a push-pull modeler. It does a very good job doing that. So I can resize things and change things very easily. So let's make sure this is set back to 4. So the thing I want to change is Cut Extrude 1, and Cut Extrude 1 was this 3-inch height. I can grab the blue ball and just click and drag that blue ball, and I can change the height of this box. And I can just resize it to anything that looks good. And I don't care what your size is, but we'll pull this up. And I think that I may want something closer to this size. For me, I like the proportions of this box. it's tall enough that I can put things in it, and it is, um, I don't know, short enough that people can still reach in there. So to me, these proportions seem about right. It doesn't matter where you set yours, but somewhere around 3.25 inches is what I have set. And in the next video, I'll show you what my completed model looks like and the additional features that I've added, but you don't need to do those for today.